All right. Chapter 9. Honestly, one of my favorite chapters. I like this one. It's all to do with triangles and solving triangles in different ways. And so, what I mean by solving triangles is like finding the lengths of sides, finding angles. Um, so, we'll do a different variety of different things. First section, Pythagorean theorem, we've done before. But there are some uses of the Pythagorean theorem that you maybe have not like talked about. So what you have talked about, a squared plus b squared equals c squared. We've used it to determine distance in chapter 1. You've done it in algebra. Excuse me. So you've used that before, but we'll do an example or two. But so we do have something called a Pythagorean triple. Excuse me. The most popular one is 3, 4, 5. So if you did 3 squared, that's 9. 4 squared, that's 16. 5 squared, that's 25. And 9 plus 16 is 25. So if you plug that into the Pythagorean theorem, you'd get 25 equal 25, which means that it is a right triangle and all that kind of stuff. Okay, so 3, 4, 5. This is one that I would memorize. Moving forward, if you saw a triangle and you just saw that, I don't need to see any work. I'm like fine with you going, that's 5. The danger is if you saw like a 3 and a 5. The other side's 4. Well, the 5 has to be the hypotenuse, the side across from the right angle. That's the longest side of a right triangle 100% of the time. Okay, so that has to happen. Okay, so if you saw this, that other side is not 4. So don't just go, oh, 3 and 5, the other one's a 4, or 4 and 5, the other one's a 3. Doesn't work that way. Okay, but if you saw that and it said X, like I am perfectly fine with you just saying that's 4. How do you know? Well, that's the 3, 4, 5 triangle. Okay, and then you can do like times 2 times 3 and so on. So you'll see, for sure you will see 3, 4, 5. You'll see 6, 8, 10 quite a bit also. It's just a larger 3, 4, 5 triangle. So the other one that comes up sometimes, not as frequently as 3, 4, 5, but 5, 12, 13. If you plug that into Pythagorean theorem, it'd work. You'd actually get 169 equals 169. And you could do times 2, times 3, times 4, again, with like that group. Won't see those nearly as much. So, times 2, you'd get that. Like that might come up like randomly, but times 3, like 15, 36, 39, you're not going to see that come up. There are a couple other ones that are listed in the book that honestly, I wouldn't spend any amount of time really like memorizing anything. Just working it out is fine. But those 3 right there, 3, 4, 5, 6, 8, 10, and 5, 12, 13 are 100% ones that I would memorize. Okay? So, if we had so the side across from the right angle is always going to be the C part, or the hypotenuse. Okay, we have legs and hypotenuse. We've talked about that before. We had that hypotenuse leg theorem way back in chapter 4, I think. But so the A and the B doesn't matter. So I tend to always put the variable first. But if you put 7 squared plus x squared, that's fine. So we have 7 squared is 49. 14 squared is 196. And then we get 145. No, we don't. We get 147. All right, so then square roots. And 147 does not have a square root. That's just a number, a number like, 13 or 14 or 15 or whatever. So we do need to simplify the square root. And this is kind of a hard one, just because 147 is not a number that you would normally think to work with. But so we kind of need to say well, what times what is 147, and then that's not an easy thing to answer either. But if there's some number theory type stuff that can be helpful, and one of those is if just add 1, 4, and 7, just those individual digits. 1 plus 4 is 5, 5 plus 7 is 12. And why do I do that? Well, it helps me with a 3 or a 9. Can you do 12 divided by 9? No. So 9 doesn't go into 147. Can you do 12 divided by 3? Yes. So 3 will go into 147. I don't know how many times, but I know it's possible. So I'm at least trying something that I know is going to work in the end. Okay. And then I can do 7 times 7 is 49. And so I end up with 3, 7, and 7. And so to simplify the square root, I want to have pairs. So I have a pair of 7s, so I write 7. Just one of them. Don't multiply them together. Don't put both 7s. You're writing I have one pair of 7s, so I write 1, 7. And then I don't have anything to pair with the 3, so that goes on the inside of the square root. Okay, and so that would be what our x is. So some of the problems early on are going to ask you to solve for x, and then they're going to ask, is it a Pythagorean triple? Pythagorean triple are the ones that we just went over. They have to be whole numbers. So you can solve the length of that side. It's just not a Pythagorean triple. And it's not a bad idea to really kind of have just a general idea of how long it really is. Square root of 144 is 12, so 147 is 12.1, 12.2, somewhere in that neighborhood. Okay, so you'll have a couple sets of problems. Solve for x, tell whether it's a Pythagorean triple. Okay, it should be pretty simple. Then, so you've done stuff like that before. Hopefully no mystery there. But we do have some other uses for the Pythagorean theorem. And one of them, sorry about that, would be to determine if a triangle is a right triangle. So let's do one that's a little bit different. Is that a right triangle? Well, it looks like it. Can't say it looks like it. So if it is a right triangle, then a squared plus b squared equals c squared will be true. So I'm just going to do 7 squared plus 8 squared equals the square root of 113 squared. Don't get intimidated by that square root thing. It's really easy. So 7 squared is 49. 8 squared is 64. When you square a square root, they cancel each other out. Okay, so if I did, I just did 8 squared is 64, and then if I do the square root of 64, I get 8. It goes back and forth. So if I square the square root, it just cancels itself out, and we get 113. Okay, and then when I add these together, I get 113 equals 113. So yes, this is a right triangle. Okay, on one of the problems, you might get something like, one of the sides is 2 square root of 3. So when you square that, it actually is kind of like a distributing. So it's like I need to do 2 squared is 4, but then the squaring the square root cancels each other out, and it's just 3. Okay, so don't do square root of 9. You could do, but don't just put 9. Some people they cancel it out and they do 3 times 3 and they put 9 right there where the 3 is, and then they do 4 times 9. Okay, so the square root part just cancels, and you're left with the same number, but then you do need to do the square of the number in the front. So if that was a 4, you would do 4 squared is 16, and so on. Okay, I think one of the problems, you'll have a square root like that also. Actually, a couple of them you will. Okay, so then that set of problems that just says tell whether the triangle is a right triangle. So it's a yes or no. Okay, and then the next set, it wants to know, well, what happens if it's not? Okay, if it's not a right triangle, well then what happens? What is it? Okay, so let's say we had side lengths of a triangle that were 4, 6, and 8. And it said, what kind of a triangle is this? Well, first I'd want to just see, is it a right triangle? So I'm going to plug it in. And then I get 16 and 36 is 52 equals 64. Okay, well, obviously that's not true. Okay, so what kind of a triangle is it? What would it look like? Okay, well, the key is the C number. Okay, so if C is greater the triangle is obtuse. That means it'll have an angle in the triangle bigger than 90 degrees. Okay, if C is smaller, the triangle is acute. it'll mean all the angles in the triangle will be less than 90 degrees. Okay, so you have a set of problems that says verify that the segment lengths form a triangle, so I'll get into that in just a second. And then, is the triangle acute, right, or obtuse? Okay, so how do I know if it's a triangle or not? Well, like what kind of triangle would it be? This one would be an obtuse triangle because the C is bigger. So one of the angles would be so I just said, well, triangle with 4, 6, and 8. So there's a definition. I don't think it's a theorem. Yeah, it's not a theorem. That basically says, it was in another chapter that we didn't cover, chapter 6. But if you take the smallest two sides, the 10 has to, it has to be bigger than 8, than like the other number. So must be bigger, larger, however you want to put it. So if I said 4, 6, and 11, you can't make a triangle out of that. So if I gave you like a piece of string that was 4 inches long, another one that was 6 inches long, and another one that was 11, you wouldn't be able to connect all of them together. Like there'd be a gap somewhere. If I gave you 4, 6, and 8, you would be able to create a triangle out of that. And then we just like looked at it, bigger than 90. Okay, so if you, and it's always just take the smallest two numbers. Technically, the definition says any two sides need to add up to be larger than the third side. Well, it doesn't make sense to add the larger one with one of the other ones because that's going to always work. So that's why the smallest two sides adding up to be bigger than the third side. Okay? All right. So you'll have a few of those. And then the last thing you'll have is area of an isosceles triangle. So if I had, and they'll all be kind of formatted like this. Where area equals half base times height. And so what they're wanting you to like look at is like you won't know the height. Okay, and so if you kind of pull this triangle out, okay, you need to know like that H, like height part. And so the reason that they say isosceles is because if the bottom is 6, I'm allowed to split it into 3 and 3. Okay, and so then I would do H squared plus 3 squared equals 8 squared. And then subtract 9. And then H equals the square root of 55. Okay, and then on your assignment, it'll work out to be like a nice like whole number. Like it would be like square root of 64 or square root of 49 or something that has a square root, because then you would plug it back into like the formula. So for this one, even though it's kind of a weird like deal, be careful because the base is that whole thing, the 6, not just the 3. So half of 6 is 3. So technically I could write the area is 3 square root of 55. That's an okay way to write it. Again, yours will be, nice. It'll be, 3 times, 7 or something. So you get 21. And so make sure, if that was the answer, that you do inches squared or centimeters squared or whatever the case may be. Okay? All right, so different uses for Pythagorean theorem. You'll have a few basic just solve at the beginning, and then they'll get into the other stuff. Okay? All right. Have a great Friday, good weekend, and we'll see you on Monday.